Hello everyone, I'm Dr. Natasha Watson and I am a senior structural engineer with Buro Happold, and I'll be talking to you about embodied carbon. Let me just share my screen. So Maddie, if you can let me know if that's working.
That's showing, yep.
Fab. All right, so let's get started. This presentation will be approximately 25, probably slightly longer, minutes long. And I'll be talking through the following: the increasing focus on climate change, discussing what embodied carbon actually is, then talking about measuring embodied carbon, the kind of systems we need to look at, the data, as well as the targets. Then the real crux of the matter, the meaty bit, is the reducing embodied carbon on our projects, what's next, and then also a summary. But first, I'd like to poll you all. How would you rate your knowledge of embodied carbon at the moment? So completely new to the subject, have some basic knowledge, understand the subject well, or consider myself an expert. Okay, it's quite exciting. I get to see the live results come in. All right, so that's around about sort of 94% of you voting. And I'm going to end polling. So there we go. So a majority of you have some basic knowledge, but a couple of you are completely new to the subject. So I think if you want to ask questions, no matter how basic you might think that they are, it's good to ask these questions. This is what this this talk is here for. Put it into the chat. All of the questions that you have been asking as part of the registration process for this, we will be collating and answering as well. But yeah, I really hope that this helps you with your understanding of embodied carbon. Cool, so that. Right, so the increasing focus on climate change. So last year, I saw this cartoon in The Economist, and we had only had around about a month of lockdown due to COVID. COVID, even now, is swiftly changing our way of life, and it already has. And climate change is not going to be any different. I mean, recently, over the past few days, we've seen that there's been flooding in New South Wales in Australia. And a couple of weeks ago, actually, there were blizzards in Texas. So climate change is already disrupting our way of life, and it's only going to continue. 2 years ago, starting with the UK Architects Declare, the construction industry as a whole, starting in the UK and now extending to over 25 different countries, declared a climate and biodiversity emergency. And that was architects, that's structural engineers, MEP engineers, everyone. As Buro Happold, we've signed, one of our partners, Mike Cook, led the signing of the Structural Engineers Declare. And within our Bath office, around about 80 of us participated in the march 2 years ago. And I think that that's very much a demonstration of the increasing public concern, the climate marches, of environment, and also that will then lead to increasing political concern as well. So the first ever climate debate was held for the 2019 elections. As a result of sort of public and political concern as well, people started making net zero carbon declarations. Now, what does net zero carbon actually mean? This is when you've got zero carbon emissions are achieved through balancing emitted carbon emissions with the equivalent emissions that are offset. So there are several people on this call that I know work either in the construction industry or are property owners or an asset owners. So you might be familiar with your own company's net zero carbon commitments. With the banks, this was a collective commitment to climate action that was set up around about a year ago that involved 38 banks. I mean, they're doing it because of the want to change, but then there's also, you know, this is a way of ensuring business continuity as well, to divest from high carbon portfolios into lower carbon portfolios. Asset owners are committed to net zero carbon as well. One particular group is the Better Buildings Partnership, which is a not-for-profit collaboration of UK property owners. And their MO is to improve the sustainability of UK commercial properties. And as part of that, there was a commitment to define their own net zero carbon pathways as well. Zero carbon targets will also be increasingly required for planning permission. So the most recent update to certain planning documents is the London Plan. And as part of this, it states that major developments should be net zero carbon, and this should be demonstrated through the calculation of whole life cycle carbon emissions, and you should show that you're demonstrating actions to reduce those carbon emissions as well. So, what exactly are whole life cycle carbon emissions? Well, a whole life carbon is the combination of your operational carbon. So these are the emissions from the operation of a building. So things like the heating and the power, plus the embodied carbon of a building. So this is my seamless segue into what is embodied carbon. So embodied carbon refers to the greenhouse gases emitted during the manufacture, transportation, construction, maintenance, and disposal of the materials used to construct a building. I'm going to talk in terms of buildings, but this could be in reference to other assets such as bridges or potentially even sort of public realm as well. Despite referring to carbon and carbon dioxide, or CO2, which is its chemical name, carbon dioxide is not the only gas that contributes to global warming. And as a result, carbon dioxide equivalents are used to measure the relative global warming potential of these different gases. So using carbon dioxide as one, I have a list of different greenhouse gases that are related to the built environment here. So methane, that's produced when there's decomposition of organic matter. So potentially the decomposition of timber that's not disposed of correctly. You've got nitrous oxides, that is a byproduct of certain industrial processes and also the burning of fossil fuels. You've got PFCs and HFCs, which are used as refrigerants. Then you've also got something called nitrogen trifluoride, which is a material that's used in semiconductors and also for LCD screens. So that's used in sort of electrical equipment. And then also you've got sulfur hexafluoride, which is a really good insulator. And so that's used in electrical switch gears, but it's also used in acoustic glass. So, it's not just carbon dioxide that we need to worry about. We need to think about the greenhouse gas emissions that are associated with our MEP systems, as well as from other sources as well. So, embodied carbon can come from several sources. Could be chemical processes, such as the leaking of refrigerants from our MEP systems. But also it can come from processes such as the breaking down of limestone into cement as well. It can come from transportation emissions associated with the creation of those building materials. So here I have the different carbon emissions associated with transportation modes. And this is sourced from, these are UK numbers, UK-based numbers from BEIS. And then also embodied carbon emissions can come from the energy and heat required for processing and manufacture. So this could be potentially the firing of bricks. This could be from kiln drying timber, the running of warehouses and things like that for precast component creation, but also the running of sort of steel mills as well. So, putting embodied carbon into context. These are 2018 numbers, but the UK annual carbon emissions from everything amounted to around about 367 million tonnes of CO2e, of which the UK built environment was responsible for around about 40% of that. If we look on a slightly more granular scale, a return flight from the UK to New York, when we can potentially do that again, is around about 1.67 tonnes per person. A train ride from Bath to London, this is if the train is full, is around about 0.016 tonnes. And these kind of actions, along with sort of eating meat as well as heating your house, amounts to an annual UK carbon footprint of around about 11 tonnes of CO2e per person. 1 metre cubed of reinforced concrete is around about 0.5 tonnes of CO2e. And so if we scale that up to create a 6,000 metre squared office building, along with the carbon associated with facades and MEP systems, etc., you can kind of assume that an office building of that size is around about 4,000 tonnes of CO2e. So that's the equivalent to the annual emissions of 363 UK-based people. So embodied carbon is a really big portion of carbon emissions if you think about it in terms of the carbon emissions that we as individuals make. And we're told don't eat as much meat, don't fly as much, but then you've got one whole building is the equivalent to the annual emissions of 363 people. So it's amazing that there's not more of a public outcry about these kinds of things. So exactly what goes into that 4,000 tonnes of CO2e? This is a breakdown of the approximate balance between operational carbon emissions, so the emissions associated with the running of a building, and the embodied carbon emissions of a building. So for an office, it's typically around about a 2/3 to 1/3 split. From that, around about 50% is substructure and superstructure, with the rest of it being things such as cladding facades, MEP systems, and then fit out. The transportation and construction of those materials is also included there too. So as you can see, superstructure is a pretty large percentage. And then from fit out, you've got predominantly sort of floor finishes and partitions, which again has a large part to play with the superstructure of a building as well. At the moment, we have a 1/3 to 2/3 split of operational carbon to embodied carbon. And that's as a result of energy efficiency improvements in legislation, so things like Part L, and also the equipment, the MEP equipment that we have in our buildings over the last 30 years. This is also a result of operational carbon being the emphasis in sustainability assessment methods such as BREEAM and LEED, and also our increasingly renewable energy mix in the UK and globally as well. Other countries are doing very well with their renewable energy targets as well. And so as a result, compared to say 1980, 1990, the embodied carbon now accounts for a much larger share of carbon emissions in buildings, and this will only increase as well. So moving on to measuring embodied carbon and talking about the system. I've already let slip a couple of things about life cycles, but I will go into depth now about what I mean by life cycle of a building component. So if we start at the very beginning, at our raw material or supply. So if we're talking about, say, a steel beam, this will be the hematite in the ground that will be excavated to produce iron ore. So each of these white boxes with a green outline are embodied carbon emissions. And each of the purple sort of tags, so the A1, that's the name of the module that you, it's the name that's given to that particular module according to the British standards for looking at the life cycle emissions of building components as well. So this will become relevant when I talk about targets and things a bit later on. So that hematite, that raw material supply, is then transported to processing, where it is refined and made into iron, potentially refined again, and then made into steel. That sort of base material is then transported to rolling mills, where you create your steel beams. And then once those steel beams have been made, those steel beams are then transported to your site, where they are constructed or installed. And then you've got your building. So at this stage, your carbon emissions are associated. You've got your embodied carbon emissions with the operation of the building. So these are things like use and maintenance and repair. So in the case of a steel beam, it might be that these beams need to be repainted every 15 years. So the embodied carbon will be associated with that repainting of the steel beam itself. If it's a case of following through the life cycle of a facade component, it might be that, say, your facade needs to be replaced every 30 years and your building has a 60-year lifespan. These emissions will be associated with the removal and replacement of a new facade system. It's within these B modules that you also come across your operational carbon emissions. So these are the carbon emissions associated with your energy use, and also the carbon emissions associated with the water usage within the building. So that's your taps, your public health elements as well. So when your building reaches the end of life and you've got your steel beam in your building and your building is being deconstructed, there are carbon emissions associated with that. You know, the unbolting, the lifting of the steel beams away from your building. And it's at this stage that this particular steel beam can go one of two ways. It could either be disposed of, so that's sent to landfill, which is unlikely for steel beams, but it might be applicable for something such as a precast element, that might be crushed and then disposed of. Or more likely, in the case of steel, it will be transported and then reused or recycled and fed back into the system, fed back into the manufacture of new steel beams. So that's the life cycle there. Now, if we look at grouping some of those life cycle elements, if we group modules A1 to A3, that can be considered the cradle to gate. So that's from the raw material supply to the factory gate. This is where you really look at your supply chain for this information. This is where you can get the most accurate embodied carbon data. If you look between modules A1 and A5, this is considered cradle to practical completion. So this is from your raw material supply to the completion of your building. And this is, again, this is the kind of, these are the modules that are typically communicated through targets, which I'll come on to a bit later as well. And then finally, if you look at everything all together, that can be considered a cradle to cradle life cycle. So yeah, that's the life cycle of a building component. If we look at measuring embodied carbon and the data that you need for that, the embodied carbon calculation itself isn't that complicated. You get your material quantity and then you multiply it by an embodied carbon rate per unit, and that gives you your embodied carbon for that particular material. So material quantities, these could either be like a bill of quantities, it could be a Revit model, you could have some sort of napkin calculations or scrolling like that. And then when you multiply it by your embodied carbon rate, it depends on whether or not you're, what kind of stage you are at in your project. If you're really early on and you're kind of looking for generic materials to calculate a sort of assumed embodied carbon for a building, you could look at the inventory of carbon and energy. So this is a free database that you can access via Circular Ecology. Version 3.0 was released 2 years ago in 2019, and it started as a research project by Dr. Craig Jones at the University of Bath all the way back in, I think, 2008. So yeah, it's the data source that I tend to go to, and it's the data source that I think a lot of embodied carbon calculators use because it's free, and because it's free, it's also transparent as well. You can really sort of interrogate the data in there. If you have a specific product in mind for your embodied carbon calculation, then you can look at something called environmental product declarations. So environmental product declarations, or EPDs, are essentially life cycle assessments associated with that particular product. It's a certification that comes with that particular construction product, and it will tell you the embodied carbon for, as a minimum, your A1 to A3 emissions, so your cradle to gate emissions, but it might also give you information based on their own sort of research or their own life cycle assessments that they've discussed with third-party accreditators. Your C1 or C2, like the emissions associated with the disposal of those products as well. It might also give you the reuse and recovery potential carbon emissions, so your D modules as well. Another source of information for embodied carbon calculations can be rates for different modes of transport. So your transportation rates, as I mentioned before, you can get them for the UK from the Department of Business, Energy and Industrial Strategy, but different countries will also have different greenhouse gas emission provisional figures as well. So with this calculation itself, you tend to follow, I say you tend to follow, we tend to follow, and it is generally accepted that a majority of people follow the Royal Institute of Chartered Surveyors whole life carbon assessment for the built environment. So this document sets out how to do these embodied carbon calculations from Module A all the way to Module D. And it also gives you assumptions that you can make for all of the other modules as well. So it gives you an assumption for your construction and installation embodied carbon. It gives you assumptions for replacement rates for different elements of buildings. So that can give you your B4 calculations. It also gives you certain assumptions you can use for the demolition of your building at the end of life. Use it if you don't want to necessarily go down the route of reading the RICS whole life carbon assessment. You could use third-party accredited items of software, such as One-Click LCA, which has built inside it different EPDs, information from the inventory of carbon and energy, and also has assumptions for all of the different life cycle modules from A to D. You could also use eTool LCD as well. I'm less familiar with that. I know that our sustainability team use One-Click LCA. It's recognized by BREEAM as well, so that's a key point there. And also in the last couple of weeks, maybe a month, there are specific system processes and assumptions for structures and for MEP calculations of embodied carbon. So I fed into the How to Calculate Embodied Carbon guide from the iStructE, and I've only just, I think in the last week, found out that TM65, which gives a methodology for MEP systems and calculating those embodied carbon, has been released as well. So I know that our sustainability team and MEP teams are on it. So I look forward to speaking to them more and learning more about that. So yes, out of this list, I would say remember the RICS whole life carbon assessment method. You can access that for free online as well. So please give that one a read. It gives a really good background of assumptions and how the process should be completed. So moving on to measuring embodied carbon and targets. I think in 2019, maybe the tail end of 2018, the RIBA set out its RIBA 2030 climate challenge for particular benchmarks for domestic buildings and non-domestic buildings. And because it was released 3 years ago, we should really be working to these targets, the 2020 targets there. Similarly, LETI, the London Energy Transformation Initiative, released a set of embodied carbon targets in 2019. And similarly, we shouldn't be working to the business as usual. We should be working to the 2020 targets for those, so that they divided theirs up slightly differently into residential, commercial, and schools. I know that one of the questions that was asked was, is there going to be alignment between these targets? And I think because this is a very fast moving knowledge area, when Letty and when Reba put forward their targets, it was very much, we need to get something out now because we need to start this conversation. And now that more and more people, I mean, the fact that we've had like 100 people or so signing up to this is a demonstration of that. There is alignment in the pipeline. So I think it will be a case of, you know, a couple of weeks, couple of months, and we'll be able to start seeing an alignment of these targets. So watch the space for that. I kind of use these targets as ensuring you're in the right ballpark. So, you know, if you've got your embodied carbon values as close to 2,000 kilograms of CO2e per meter squared of your building, you know, you've got a lot of work to do. However, if you're sort of around about the 1,200 or you know, 800 or so, then you know that you're kind of in the right ballpark and you can then make improvements. So another segue into how to reduce the embodied carbon of your projects. I think if there's one thing to take away from this is that the earlier you tackle embodied carbon, the bigger the potential savings. You know, it's something that needs to be discussed really early on. But that is not to say that, you know, if you're coming at this and your project is already at, say, Reba stage 4 or something, you can still make improvements. So I've distilled our advice into 5 key points here. A key one is reuse over new build. So this could be, for example, using your existing building more effectively. So the Buro Happold SMART team do a lot of people flow modeling to show how you can use your spaces differently. So it might be that you don't need a new building at all. You just need to sort of change a couple of partitions around, or change the program of the spaces around a bit, and then you can actually achieve what you need your spaces to do. Potentially you could reuse your superstructure and foundations and then replace the facades. This is an image of Lakeshore, which is based in Bristol. It's an old tobacco headquarters, Will's Tobacco headquarters, and it's been converted into housing. So what they've done is reuse the superstructure and the foundations, but also cut an atrium in the middle to allow for more natural light there. Or you could potentially only reuse the foundations. I mean, that's still reuse, and that should still be promoted. And there is quite a bit of guidance there for the reuse of foundations. This might be especially appropriate in sort of built up cities such as London, and our ground engineering team know more about this. Second one is to challenge the brief. I could have gone into a lot of detail here, but I think the main takeaway I wanted everyone to have was to challenge the size of your grids in your buildings. Regardless of if you have a concrete frame building, a steel frame building, or a timber building, if you can reduce the grid sizes, it doesn't have to be as small as 6.5 by 6.5, but any reduction in your grids will have a significant reduction on the embodied carbon of your superstructure and your substructure. So yeah, I think challenge your brief. Do you need to have a 9 by 9 or a 12 by 12 or a 15 by 15 grid? Yeah, that's the key challenge I want to leave you with there. Number 3, specifying low embodied carbon materials. I think the key thing here is you can't really compare a material's embodied carbon per kilogram of that building material. You need to think about how much material is needed for a component to do its job. So, for example, on this image on the left-hand side, you can just about see that timber scores higher than concrete in kilograms of CO2 per kilogram of material. However, if you look on the right-hand side, where you see the weight of the beam that you need to span 7.5 meters for any given load, you need 10 times as much concrete than to timber for that particular component to do its job. Fourth, design efficiently. So I didn't want to, even though my structural engineering is my background, I wanted to make this a bit more discipline agnostic. To ensure that we can design efficiently, we need to make sure that we can optimize our designs, and that requires us to have design freezes and potentially even a design optimization stage in our program. It allows to work with the different drivers for your building, you know, your cost, your quality, the embodied carbon, and it allows for all of the different elements to go through a period of refinement and a period of optimization, so that the material that is being used as effectively as possible. In more of a structural engineering vein, though, it could be a case of, you know, looking to the future, we create 3D printed connections, 3D printed members, so that we are only using material where it's needed. And then also with that, you know, the more and more we use computational design as well to harness the power of parametric design to only put the material where it's needed when we're modeling as well. And then lastly, design for deconstruction. So with this is about reducing the carbon emissions associated with your C modules. So the modules associated with disposal and demolition and deconstruction and so on. So for this, it feeds into the circular economy, because there won't be any materials that are disposed of, because it's going to consistently be within the economy of buildings. So for this, we need to ensure we have good record information. You know, if you're going to be deconstructing your building and then giving your steel beam to someone else, they need to know what they're getting. Need to have simple reversible connections between different components. So things like bolting, not welding components together, not gluing components together. Aiming for single material and non-composite elements. Minimizing the number of different components and materials as well, to really make that deconstruction of your building when it reaches the end of its life an easier thing to do and a much more likely to happen. And then also in that similar vein, eliminating secondary finishes to materials as well. So what's next? How are we, Buro Happold, delivering to this commitment? Well, we're giving presentations like this, but also we're investigating further into how structures and facades and MEP work together with embodied carbon. So it might be that what's best embodied carbon wise for structures might not be great for MEP, might not be great for facades. So we need to actually work together and ensure that, you know, when we give advice, it's the best for the building as a whole. And that's one of the benefits of working in a multidisciplinary company, is that you can have those conversations and you can investigate those different areas. We're also feeding into industry guidance and feeding into sort of university projects and things like that as well. We're educating our staff members. I know that I've been a part of educating the whole of our UK structures in embodied carbon. we're measuring and evaluating embodied carbon on all of our projects now, regardless of if clients ask for it. It's to help us upskill ourselves and also to help us, get a feel for what good is and what improvements you can make. It's a skill that we need to keep honing and keep improving on. And we're also beginning to report the embodied carbon of our different projects as well, alongside our rating systems, which is aligned from a structures point of view. It's aligned with the scores rating system that was released last week as well. And then, the next steps and further workshops, there's going to be a bit more information about facades and sustainability next week. So that's with Antonella and Daniela. And then also my colleague Jonathan will be talking more about structures specifically in April. And then as part of Reboot, there is more in the pipeline as well. So in summary, embodied carbon is increasing in importance as operational carbon continues to decrease. There will be a consolidation and alignment of the REBA and LETI targets. Please give the RICS Whole Life Carbon Assessment guide a read through. It's a really good starter for 10 for looking to calculate the embodied carbon of your next project. If you can, calculate the embodied carbon of your projects from A1 to A5 as a minimum. So that's your cradle to practical completion. The earlier embodied carbon is discussed, the higher the potential savings. Reuse existing buildings wherever possible. If you can't reuse the whole building, try and reuse the superstructure and substructure. If you can't reuse the superstructure and substructure, try and reuse the foundations. And then finally, you can't compare a material's embodied carbon without considering how much of it is needed to do the job as well. So a whistle-stop tour through embodied carbon. And now for a second poll. I was wondering, how confident are you now at talking about embodied carbon? I'm hoping it goes up. 75% of you have voted. Right. I think we're, there's around about 80 or so people who have voted. So, a few more are coming in. I'll end the polling there. So, considering the poll at the beginning, I feel like I have done my duty. One person not very confident at all, but that's all right. I mean, if that person wants to get a hold of me after this to discuss more, I'm happy for that. Oh, I haven't shared the results. There we go. So yes, that's the end of this presentation. And like I said, if you want to ask me any questions or get in touch with me, I'm always happy to talk about embodied carbon at length, probably. But yeah, I hope that was useful for you all. Thank you.